Hello, fellow NASA HUNCH students and teachers. My name is Miss Brittany Koger, and I'm going to be walking you through the second investigation station for our microgravity dice game project. All right, so I did this project with my fifth graders here in Georgia because magnets and magnetic fields is a big standard that we cover here in Georgia for our fifth graders that have to take our Georgia Milestones test at the end of the year. So we chose magnets and microgravity because we're talking about a dice game that is going to be in space, that they're going to be playing on the International Space Station. They're going to be playing on missions to the moon and to Mars. It takes 9 months to get to Mars and 3 days to get to the moon. Some people, astronauts, when they go up to the International Space Station, they stay anywhere from 30 to 180 days. It just depends on their mission and what they are there to do, and what research they're there to do on how quick their mission is. But we want them to feel normal up in space. That is the whole reasoning for doing this project, is to help with their mental health as they are up in space. You got to think about being on a very small spacecraft for a very long time. It's very cramped and crowded. It's very odd, and things are not how they normally are. Things float. You're not used to your environment already. You're taking out of your comfort zone. You're in a new space. So we want our astronauts to feel as normal as possible, and we want them to have something fun to do, not just all research. So that's why we're trying to develop this microgravity dice game for them. A lot of games involve dice. So with my students, we talked about ways to connect dice to a dice board, and we chose magnets. So that's what today's test is going to be, and this is station number 2, and this is the magnet test station, and we're going to be testing different types of magnets today. All right, so you are going to need several things for this station. All right, you're going to need some measuring tools for this one, and it's actually not too bad to use a ruler for this station. The magnets don't pull like 3 feet away, so you can just use a regular ruler, which is what we're going to do today. And I'm going to try to zoom this in so you can see kind of how I do and how I did this with my students. So first, you're going to need rulers. I would go over how to read a ruler. If you've already done the weight and measurement, your students should know how to read a ruler, but always remind them to start at 1 on the inches side and go across that way. There are 16 little parts of an inch, so to count each little mark and write it down as a fraction. If it is 1/4 of an inch, we say 1/4. If it is 3/4, we say 3/4. So make sure that you're using the ruler and using it correctly. All right. So we're going to have our ruler down on our table. You're going to need several different types of magnets. So the magnets that I have today, I have a round refrigerator magnet. I have a lovely bar magnet, which I have a ton of these in my classroom for some reason. I don't know where they all came from, but I do. I have one of these. This is a very strong neodymium magnet, and it's a very big, strong one. I got it at a parts store. And then there is this one, which I have 2 of these. You throw them together, and they kind of make a weird noise. They connect together. They're those little toys that are like that, and they're rare earth magnets, and they stick together, and they're really cool to make that weird noise with. That noise that I like so much. So I have a rare earth magnet as well. Use whatever magnets you can. Go to the Dollar Tree, Amazon, parts stores, Walmart. Any of those places have magnets. And you're going to need some pieces of metal as well. So I like a paper clip. I use paper clips a lot with this. This is because they're very lightweight and it's easy to pull them to a magnet. I have a little piece of just a little metal piece that came with my magnets. I have a metal washer and a nut that goes to a bolt. Those are my pieces of metal that I'm going to be testing with this today. And we're testing to see how far away a magnet will react. Because when we are making this game, and it's going to be floating around in space, our spacecrafts have lots of electronics. And if you do not know, magnets do not interfere well with electronics. They can really mess up your screen on your phone, computer, TVs, cameras, anything like that. It can really mess things up. So we don't want to mess up any of our electronics. We want our astronauts to stay safe. So we don't want to cause them any harm. So we need to know how far away these magnets are going to work, because we don't want it to, attract something from further away. So that is the reason that we are testing this today. So I'm going to show you how I did this with my students. Just quickly, I'm going to show you a couple of items and how we did this. I'm going to try to get this to zoom in a little bit on my hands so you can see how I did this correctly. All right. And I have a little metal ball as well, a ball bearing, and we use that later on in this project as well. So I wanted to make sure that I showed that to you guys today. All right, so I'm going to try. So this is our 0, and we're going to put our paper clip right here at our 0. All right, we're going to start out with our paper clip. And I'm going to start out with my weaker magnet, this round magnet. And I'm going to start down here at 6 inches. And I'm just slowly going to push it this way and see how close I can get to this paper clip without attracting it. And remember, an attraction is pulling together. Repelling is pushing away. And we want it to attract that paper clip. All right, let's see. 1/2 inch. It was 1/2 inch before I attracted this paper clip. All right, let's see if I can get that reading again. Oh, yep. 1/2 inch for this round magnet is what it's going to be. All right, so now I'm going to put my paper clip back. I'm going to grab my other magnet. I'm going to do the same thing. I'm going to start kind of further away. Ooh. And I'm going to push down. And I'm going to try to see how close I can get. Ooh, I'm already attracting it. At 3/4 inch is when that started to attract. Let's see if we can get that reading again. And it's trying to stick to my ruler as well because there's a metal thing on my ruler. So I don't want it to stick to my ruler. Yep, 3/4 inch for the bar magnet. All right, we're going to put that one to the side. We're going to use this rare earth magnet. All right, let's see how close we can get. And again, it is trying to attract to my... Oh, 1 inch there. All right, let's see if I can get that again. Yep, definitely 1 inch on this rare earth magnet. All right, let's try this neodymium magnet. This is the one I'm very interested to see because it is a very strong magnet. All right, let's see. Oh, it's attracted my ruler. I'm going to have to get a plastic ruler for this one next time. Oh, 1¼ inch. See if we can, oh, yep, look, 1¼ inch. Let's see. 1/2 inch is where we're at with the neodymium magnet. All right, so then you're going to do the same thing with the other materials. Let's try the little metal ball. We're going to do the same thing again. We're going to push it, get it close to it, see how far away it attracts it. Boom. About 1/4 inch for that one. Let's get our bar magnet. 1/2 inch on that one. Let's get our rare earth magnet. That one was about 1/2 inch, so I'm very surprised because I thought that one would get it at about 1 inch, but it's about 1/2 inch for that one. All right, now let's try our neodymium magnet. Let's see how far away it can get. I can already feel it pulling it, and it's at 3 inches. Look at that. It's already kind of pulling it that way. All right. Oh, 1.5 inch. So that's going to be about as far as we're going to get with that. As close as we can get with our magnets there is about 2.5 inches away. So that's actually good data because that's not going to pull too many things far away into it. If we don't have a magnet that is stronger than that one, it's going to be about that. And this one was about 1 inch away with that heavier piece. So that's very good data. That's what we need to write down. And fill in the slides. Each one has the material and the magnet and how far away it pulled or attracted it to it. Like I said, remember, attract means to pull together. Repel means to push away. And magnets attract and repel different types of metals, only metals. So don't think that they're going to stick to wood or anything like that because magnets only stick to metal. So go into a lesson about magnets. Take your time. Go over all of the standards that you need to cover for your students before the end of the year. And go into those attract, repel, opposites attract. The same poles repel each other. So a north pole is going to repel a north pole. They're going to push away from each other. A south pole is going to push away from a south pole. They're not going to go together. There's going to be a field there and you're going to feel it and it won't go together. Now a north and a south, boom, it's going to pull right together because that's the attraction there. And our Earth has a north pole and a south pole, and we have a magnetic field around our Earth, and you can go into our Earth's magnetic field as well. All of those videos will be in. I have a couple of links to those videos and some magnet videos at the end of this station that you can kind of watch with your students if you would like to go over those. The most important thing is to have fun with this. Record your data. Talk together with your group, talk about it whole group, figure out which magnets were the strongest, how far away they can attract different metals, and record all of that data because that data is going to be very important for our end design. I hope you guys had fun with this station. I will see you at our next station, the dice investigation. We're going to be investigating some different dice and how they act and react to different things. All right. So I hope you guys have fun. Have a wonderful day. See you later, guys.